Vulcan worlds. The mystery of how blistering hot Vulcan planets may form may now be one step closer to being solved. In the past 2 decades or so, researchers have confirmed the existence of more than 1,800, yes, I said 1,800, exoplanets orbiting distant stars. These discoveries have revealed very different kinds of exoplanets from those seen in the solar system, such as super-Earths, which are rocky worlds up to 10 times the mass of Earth, or they're Earth-like planets with deep oceans. They're ocean worlds. No biggie. There's probably life swimming around on them. Large creatures like the megalodon. Right there, right in front of us. Use your imagination, physicists. Come on now. Unexpectedly, astronomers recently found a new class of alien planets. Worlds in the Earth to super-Earth range, whose orbits, which are tightly packed together very near their host stars, range from just 1 to 100 days long. Most of these planets are both far larger and much closer to their stars than Mercury, which is only about 2/5 the diameter of the Earth and has an orbit of 88 days long. So we have an object orbiting around its host star in 1 day. 1 to 100 days. Can you imagine having a year that's 1 day long? That would make me like, what, 80,000 years old or something? Almost 99% of the Vulcans are in orbits that are smaller than Mercury's orbit, said study co-author Jonathan Tan, an astrophysicist at the University of Florida in Gainesville. Sorry, I'm not a Gator fan. Knowles. Some are 100 times closer than their star than the Earth is to the Sun. So we have this little finding here. Alright, I'm going to just go into it right off the bat. Basically, Tan and his colleague, Chatterjee, produced a theory known as inside-out planet formation that may solve the mystery of how Vulcans take shape. It suggests that these worlds originated in the scorching close orbits they occupy now, from a stream of pebbles and small rocks that spiraled inward from more distant parts of the system. These stones accumulate in a ring around their star and kept from getting any closer by pressure forces in the inner disk around the star. Tan said, "We hypothesize that a planet will eventually form from this ring and will keep growing." Okay. These findings were published, I think I should put them on the bottom of this page. These findings were published online on December 29th in Astrophysical Journal Letters. I'm going to find where that paper is and post it on the bottom here. So basically they have a disk theory again. They know those disk things, and none of them can explain how the angular momentum is lost. They just ignore it. But wait for it, I have the solution to explaining what a Vulcan planet is. Okay? Now, let's use our creative thinking skills. Put your thinking cap on, people. What orbits close to its star? You have 2 types of new planets now. 1, Vulcan planets, which are rocky worlds. Okay, they have really close orbits. And what's the second type of object? Think about this for a second. What other object orbits really close to its host star? Ah, yes, hot Jupiters. What would happen if a hot Jupiter just kept on orbiting a host star and had its outer atmosphere ripped away? It would become a Vulcan planet. Problem solved. You're welcome.